Hello and welcome to the first video in the series for extending the Home Builder Library. This video is an introduction to assemblies. Assemblies are the basic building blocks that are used when creating parametric assets. In a way, you can think of assemblies as smart objects. But rather than just being a static mesh, there is information added to the asset that allows it to change size in a logical way. It allows it to snap together to other assets in an intuitive way, and it can provide a number of controls that can change the look and behavior of the asset. HomeBuilder uses this structure for all of the assets in the library. It allows for a wide variety of functionality that not only makes the assets very simple to use, but also allows you to extend the library by creating assets in a specific way and allow them to be loaded into the library and easily accessed from the built-in interfaces. An assembly is just a specific structure of Blender's empty objects. One object acts as the base point, which all other objects are parented to. Then we have an object that controls the X, Y, and Z dimension. This determines the size of the assembly. And finally, we have an object that stores the prompts, which are all of the options that change the look or behavior of the asset. Apart from the objects that make up the main structure, assemblies can have as many other objects as needed, including mesh objects, curves, lights, cameras, or even other assemblies. In order for an object to be included in an assembly, it just needs to be parented to the base point object. To help you understand how assemblies work, let's jump into Blender and create a simple assembly from scratch. So as long as you have the PyClone add-on enabled, here in the Add menu, we'll have a new option to add an assembly. And so if we click that, here we can give the assembly a name. I'll go and keep the defaults and click OK. And so this adds the main structure of an assembly to our scene, but to get a better understanding of how this is structured, let's go ahead and switch from the file browser to the outliner. And so this shows us a hierarchy of all of the information that's currently in our scene. And so here we have the base point of the assembly. If we expand this, this shows all of the objects that are parented to that base point. And so we have the X object, the Y object, and the Z object. We also have an object that stores the prompts, which we'll get into in just a bit. But here, if we select the base point and go to the Move tool, you'll notice that here, if we move the base point, that's going to move the entire assembly. But if we select the X dimension object, you'll notice that it only moves along the X axis here. We can move that. Here, the Y only moves along the Y, and the Z object only moves along the Z. If we want to take a look at the properties, here we select the base point of the assembly and right click. Here we can access the assembly properties. And so here, this shows us the dimension of the assembly. And you notice that we can change this and that will update the location of the X dimension object. So here we can just make these changes inside this interface. Now, if we want this to be always docked to the interface, here if we type N on our keyboard, that will open up the sidebar, and you'll notice that here in the Assembly tab, we have the exact same information. So this is the exact same information that's shown in the Assembly properties in the right-click menu. But right now, we just have the minimum structure of an assembly created. So let's go and add in an object to our assembly. So if we go to the Objects tab, here we can click Add Object. Here we can specify the type. We'll go and leave it on Mesh for now. Here we can give it a name. Here we'll just type in Cube, and we'll click OK. So that's going to add a cube or a mesh object that takes up the entire bounds of the assembly. But you'll notice that the cube does not change dimensions with the assembly. So we can change the size of the dimensions, but the cube is static. It's not going to update. And you'll see here if we go to Objects, here for the cube, if we use this drop-down menu, this will show the properties specific to the cube. So it looks similar to the properties of the assembly, but you'll notice that if we make adjustments here, it's just updating the cube object that we're working on. And so if we want the cube to update the size along with the size of the assembly, here if we go to the Data tab, here this will show us the data of the mesh object that we're working with. And here we can click this to enter edit mode, or we can type tab on our keyboard to toggle between object and edit mode. But when we're in edit mode, we have these options to assign the vertices to the X object, the Y object, and the Z object. And so here, let's go ahead and just select some of these vertices that we're going to assign to the X object. Here I'm just holding down Shift and I'm selecting these vertices. And so now I have 4 vertices selected that we're going to assign to this X object. So if we click on this button right here, that will assign those vertices. You'll also notice that it gives us a number here, which is how many vertices that are currently assigned to that object. Optionally, we can also switch to face select mode. So here we can just select a face, and this is essentially the exact same thing as selecting those 4 vertices, just a little bit quicker way to do it. And so here, let's go ahead and assign this top face to the Z dimension object, and then we'll select this face here, and we'll assign that to the Y dimension object. So you can see that we have 4 vertices assigned to each of these objects. At any point, if you ever make a mistake, you can always clear all the vertex group assignments, and that will just kind of start you over from scratch. But if you want to connect those vertices, you then click Connect Hooks. That will bring you back into object mode, and so now when we change the size of the assembly, you'll notice that it's going to also change the size of the mesh object that we're working with. Now all that's happened here is here if we switch from the outliner space to the properties space, this will show us the properties of the active object that we have. So here if we go to the modifiers panel, you'll see that it's added these 3 hook modifiers. And if you ever want to disconnect the hook modifiers, you can either select the apply button or you can just delete the modifiers that are assigned to the cube. Next, if we want to assign materials to this object, we can basically use the exact same information that you would use for any other Blender object. You can add as many material slots as you'd like. You can create the node structure to define the shader for the material. But here, if we do this within the assembly panel, here if we switch to the material tab for the cube object, here we have the same information. So here if we add in a material slot to our cube, you'll notice that it's adding in the exact same information here. It's just created a new material slot. But one thing that's important is that within PyClone, we allow a material slot to be assigned a name and a pointer. And this is assigned to each material slot. So here if we have another slot added, here let's say that we want to assign the second one. The name of this is going to be the top face. And so if we just type in top face, this just lets us know what faces are assigned to each material slot. And in order to assign these to the material slot, here if we type tab to go into edit mode again, here with this selected, we can select the face that we want to assign to the material slot. We can click on our material slot and click assign. And now we've assigned this top face to this material slot. And again, here in PyClone, we just have that name just to be used as an easy way to let us know what information is assigned to what slot. So here we'll type tab to exit edit mode. Now this next parameter is the pointer that we're going to assign to this material slot. And here if we switch back to the file browser and go into the material interface, these are all of the pointers that are currently available in the Home Builder library. And so we can see here we have this pointer called countertop surface. And the material that's assigned is called Midnight Granite, and it's in the sample category. So right now I just have the sample library installed. So here's the category that we currently have selected. And here if we select this, this shows all of the material. So right now this Midnight Granite material is assigned to the countertop surface pointer. And so what we can do is here in the pointer field, we can just type in countertop surface. And if we go back to the interface here, if we click on update materials, you'll notice that now this material slot has been assigned that Midnight Granite. You can see that updated here on our mesh object. Now I'll get into materials in a later video, but if you wanted to change the material that's assigned to the countertop surface, let's say that we wanted it to be this polished chrome material. Here we can select that material. So this is our active material. And now we can click on the pointer that we want to assign that. So once we click on that, you'll notice that this has been updated. So now the countertop surface is the polished chrome. And here if we click update materials, that has updated the material that's assigned. You can see here in this material slot, it's assigned to polished chrome now. And keep in mind that we can have as many objects as you want. You can just continue to add objects through this interface. If you wanted to add a mesh object that you've already created here in the outliner, here if we just had some other object, let's say this Suzanne object here, if we wanted to add this object to our assembly, all we do is just drag this onto our assembly. And here we have to hold down shift. You'll notice that in the context information near the cursor, we have to hold shift to parent. So if we hold down shift and then let go of our cursor, that's going to parent the Suzanne object to our assembly. And you can see here, we now have the cube object and the Suzanne object assigned. But for right now, we'll just go and just delete the Suzanne object. And now let's add some prompts to our assembly. Prompts are very similar to custom properties in Blender. Here, if we switch to the properties interface and go here, Blender, you can add as many custom properties to objects as you want. And so you can see there's already a couple defined in the API, but here if we click add, this adds a new property. Here if we click edit, we can give it a name. We can give it a value, we can give it a min and max. There's some options that we have, but this is very limited on what we can do here. And so here, let's go and just delete that for right now. So prompts are very similar. Here we can add in a prompt to our assembly. We can give it a name, and then here we can give it a type. And so this is very powerful. Being able to assign what this is supposed to control, whether it's a distance value, an angle, a quantity, percentage, a checkbox. Here you can determine how the user is going to interact with that property. So let's add a checkbox value here, and we're just going to call this hide. And we'll click OK. And so the idea is that we want this prompt that we just added, this hide prompt, to hide the cube. So when we turn that on, it should hide the cube. Right now it's not connected to anything because we have to set that up within the logic panel. And so what we're going to do is we're going to switch to the logic panel, and this shows all of the drivers that are assigned to this assembly. And so here we can see the drivers for the location, rotation, dimension, but the most common one you'll use is the selected object. This will show all of the drivers for the currently selected object that we have. Right now this cube doesn't have any drivers assigned to it, so let's go ahead and add one. We'll go to the objects panel, drop this down. Here in the main tab, we have this ability to disable this object in the viewport. And so what we're going to do is we're going to right click on this value, we're going to select add driver. This opens up this interface, but it's a little bit confusing to use this within Blender, and so we'll just go and move our cursor away to get rid of that. But you'll notice that this value has now changed in color, letting us know that it's driven by a formula. And so now if we go to the logic panel, here we have one driver that's created. Here you can see that the driver is the hide viewport option. It's currently equal to false. Here, this is going to be the expression or the formula that we're going to enter in for that property to evaluate. And then below that, these are all of the variables that are included. So Blender always includes this default one, which doesn't evaluate to anything, so we can just delete that. And here, if we click on this button right here, this will access all of the variables from the new assembly that we created. And so here, if we select this button, this will show us all of the variables that we can access. So we have dimension, location, rotation, and also any prompts that we've added. And so here we can check any options that we want to include, click OK. And so now we've added those two variables. So we have the dimension X, which is currently evaluating to 1 meter, and we have the hide property, which is currently set to false. And so to connect that property with the new prompt that we created, here we can just copy this variable name and then just paste it into the expression field and type enter. And now when we change this value, you can see it will update that property. But this is a pretty simple example of what we can do. Just to make something a little bit different, maybe we want to hide the cube if the X dimension exceeds 2 meters. And so here, we can type in our formula bar. Here we'll use an if statement. So we'll use if, we'll use open parentheses, and then dim x, which is that variable that we added. So if dim x is greater than 2, we're going to go ahead and set this to true. Otherwise, we'll set it to false. Now, I'll be creating some more advanced tutorials that will explain different ways of creating these expressions, but for now, let's go and just type enter. And so now if we go to the main tab, and so now if we change the X dimension, and if it exceeds 2 meters, you'll notice that it will hide that cube. So it's just an example of how you can write a formula to determine what a property should evaluate to. So here we've just created a very basic assembly. They can get much more complex than this. And to show you a real example, let's go and take a look at some cabinets from the library. So here I'm just going to go and create a new file. And let's go and drop in this 2-door base cabinet. And we'll go and select on a part. We'll type N to open up the sidebar panel. And so here in the assembly tab, we can see that we currently have a door panel selected. So here we can see the assembly for that door panel. And if we select the left side, we can see that we have the left side. Here, this is the top. We select this part here. So you can see that each one of these parts is its own assembly. And you can see that a lot of these values are driven by drivers. So if we take a look at the X dimension for our toe kick, this is the length of the toe kick here. And so we can see that the formula is evaluating to width minus material thickness times 2. So it's basically taking the width of the cabinet and then deducting the thickness of the material for the left side and the right side, which is then giving it the interior width of our cabinet. Here, if we take a look at the Y dimension, this is evaluating to the toe kick height, and the Z dimension is evaluating to the material thickness. You'll also notice that these assemblies can have their own prompts. So here we go to the prompts for the toe kick assembly. Here we have that same property hide, which is pretty common to include just as a quick way to be able to turn on and off parts. But this cabinet is just essentially a bunch of assemblies that are combined together. And so if we take a look at the outliner for this product, here we have the base point of the entire assembly, so the base two-door cabinet. If we expand that, we can see that this has two other assemblies for the carcass and the countertop. Here, if we open up the carcass, we can see that there's other assemblies for the back, bottom, doors, left side, all the different parts in this assembly. And we can just take a look at all of the information by just selecting here in the hierarchy. Now, if you don't want to navigate the assembly structure in the outliner, if we go to the base two-door cabinet, you can notice if we go to the objects that are currently in here, you can see that we have the carcass and the countertop. And here, this icon is a cube, which just represents that it's an assembly. And so here, if we click on the carcass, you'll notice that it navigates, basically selects that carcass, and we can see now all of the objects that are in the carcass. And so you can kind of drill into the different assemblies, see the information that are assigned. Now, if you want to go up one level, here in the assembly dropdown, there are a few different options, some that are pretty self-explanatory, like delete assembly, duplicate assembly. Select base point just targets the base point of the assembly, but we have this select parent assembly. And so if we click that, you'll see that it goes up one level. So now we're back in the carcass, and again, we can do that one more time to go back to the main assembly. There are other options that will be included in here. Right now, this create assembly view is something that's currently being developed, which is just a way of creating a printout for this assembly. And I'll be creating more videos on that soon. But this is everything that you need to know about the basics of how assemblies work. The next two videos will get more into working with standard objects and materials. And the last two videos in this series will walk you through how to create more complex assemblies. So we'll walk you through how to create and save new appliances. I'll show you how to create a new door panel from scratch, and you'll see how you can just create one parametric part and then swap out that one part in your entire design, which is a really powerful concept. So thanks for watching this video, and I'll see you in the next one.